Hi students, this is Miss Oberly with Lesson 6-2, parallelograms. By the end of this lesson, you will be able to recognize and apply properties of sides, angles, and diagonals of parallelograms. Let's start with some of these properties. First of all, if you know that something is a parallelogram, then you know opposite sides are congruent. If you know that a quadrilateral is a parallelogram, then you also know opposite angles are congruent. 6.5 says if a quadrilateral is a parallelogram, then consecutive, which means in a row, so like angle J and angle M, angles are supplementary. So these two angles would add up to equal 180. And 6.6 says that if a parallelogram has one right angle, then we know all four angles will be right. Let's use that in example 1. In parallelogram ABCD, suppose the measure of angle A is 55 degrees. I'm going to write that in. And AB is 2.5 feet, and BC is 1 foot. Find each measure. Well, first the measure of DC. We just learned that opposite sides of parallelograms, which we know by this symbol, are congruent. So this side must therefore be 2.5. Measure of angle B. Well, we know that opposite angles are equal, so this will be 55, but we're trying to find the measure of angle B. Consecutive angles will add up to 180. So we can say 55 plus measure of angle B equals 180, and therefore solve to find this to be 125. Which then tells us that since opposite angles are equal, this must be 125. Measure of angle C we just found using that opposite angle theorem. All right, 2 more theorems. First is that if a quadrilateral is a parallelogram, then its diagonals bisect each other, which remember means cut each other in half. So these diagonals cut each other in half, which means that this segment equals this segment and this segment equals this segment. If a quadrilateral is a parallelogram, then each diagonal separates the parallelogram into 2 congruent triangles. So triangle ABD is congruent to triangle CBD. So let's use that. If QRST is a parallelogram, find the value of x. Well, let's look at x. Remember, we know that opposite sides are congruent, so we could set those equal to each other and solve. Find the value of y. Well, we just learned, remember, that diagonals bisect each other, so that means that these 2 segments are equal, so I can set them equal to each other to solve for y. To solve for z, let's see, where is z in our picture? Here it is. I'm going to have to use the idea that diagonals form 2 congruent triangles. So I know this triangle is going to be congruent to this triangle. And if I know they're congruent, then I know that corresponding parts, such as these angles, will be equal by corresponding parts of congruent triangles are congruent. And therefore I can say 3z equals 33 and solve for z. Z is 11. Our final example uses coordinate geometry, so it might be helpful to have a little bit of graph paper handy. Determine the coordinates of the intersection of the diagonals of this parallelogram with these vertices. I like to first picture what I'm working with, so I'm going to turn to my graph paper and quickly plot these. -2, 4 is right here. 3, 5 is right here. Maybe make those bigger. 2, -3 is right here. And -3, -4 is right here. So if this is my parallelogram, which I should really be using a line tool to do this. All right, so if this is my parallelogram, and we're talking about finding the diagonals or where they intersect, we know it's going to be somewhere in that vicinity. So I want to start by focusing on 2 points that actually are across from each other. So I would maybe focus on, let's see, -2, 4, and let's see, 3, nope, not that one, 2, -3, or these 2 points. And then we're just going to find the midpoint of them because we know that they bisect each other, and that will find our point of intersection. So, for example, we could take -2, 4 and 2, -3, find the midpoint. Remember, we add up the x's and divide by 2, add up the y's and divide by 2, and that gives us 0, 0.5. When we look at our graph, does that look approximately right? It sure does.